So we're going to dive into Newton's second law a little bit more today and really look at how we can mathematically describe the relationship between a net force and an object's acceleration and its mass. So at the end of this, you should be able to mathematically describe Newton's second law and solve problems involving Newton's second law. So the summary questions in your notes need to be: how is Newton's second law mathematically represented? And how do you determine the net force acting on an object? Newton came up with his second law as a model to describe an object whose motion is changing. Newton's second law says an unbalanced force results in a change in an object's motion. Remember, we defined a changing motion as an acceleration, and this means that the object can be speeding up, slowing down, or just changing direction. There are three variables described by Newton's second law that we want to relate to each other. The net force is the overall push or pull acting on the object. The mass is a measure of the amount of matter in an object, and the acceleration is the rate at which the object changes its motion. Mathematically, Newton's second law says the acceleration of an object is equal to the net force divided by the mass of the object. This means that the more net force we have acting on an object, the more it's going to accelerate. Conversely, the larger the mass, the less the object is going to accelerate. This echoes Newton's first law of inertia, right? The more mass an object has, the harder it is to change its motion. In its more common form, we can say that the net force is equal to the mass of the object times the acceleration of the object. Now, I want to point out that when we talk about the force that changes an object's motion, we are talking about the net force. So it is not necessarily a certain force acting on the object, but the sum of all of the forces acting on it. One of the most beautiful things about physics is the combining of units to create new units. Remember that derived units are the ones that we make up from other units that have been multiplied or divided. So when we multiply mass times acceleration, we get an algebraic combination of kilograms times meters per second squared. This combination gives us the SI definition of the Newton. So the specific definition of 1 Newton is the amount of force that is needed to accelerate 1 kilogram of mass at a rate of 1 meter per second squared. So let's try an example. A 650 kilogram car accelerates at 4 meters per second squared south. What is the net force acting on it? Pause for a second and see what you can get. Okay, so what do we know in this problem? We know the mass of our car, and we know the acceleration. We're trying to find the net force. Which equation are we going to use here? The net force equals mass times acceleration seems appropriate. So the net force is equal to 650 kilograms times an acceleration of 4 meters per second squared. And this is going to give us a net force of 2,600 newtons. Now don't forget that a force is a vector, so we want to include the direction. The acceleration was to the south, so the net force must also be to the south. Try this one. A 5 kilogram block is pushed to the right along a frictionless track with a force of 10 newtons. What is its acceleration? Pause for a minute and work through this problem. So here we are given the mass of the block along with the force being applied to it, and we want to know the acceleration. So we want to use the acceleration form of Newton's second law, but what is the net force? A lot of times it's a good idea to sketch out a force diagram to help us visualize where those forces are going. So we're on Earth. We have the force of gravity acting on our block, and it's acting in the down direction. Since it's not stated otherwise, we can assume the track is level, so the normal force will be acting in the up direction. Since the force of gravity and the normal force are the only two forces acting in the vertical, we can say that the vertical forces are balanced and there is no acceleration either up or down. Now the applied force is acting to the right and there is no friction acting on a track to take away from that. So the net force acting on our block is completely due to the applied force. Remember that we typically refer to the right direction as the positive direction. So the net force acting on the block is 10 newtons to the right, or a positive 10 newtons. Now we know the net force and the mass, so we can plug that into our equation. And 10 newtons divided by 5 kilograms gives us an acceleration of positive 2 meters per second squared. All right, one more. Let's take that same block and we're going to push it to the right along a track with a force of 10 newtons. But now we have friction between the track and the block, and we find that to be 3 newtons. What is its acceleration? Pause for a minute and work through this one. In this problem, we are given the mass of the block along with the force being applied to it and the force of friction. We want to know the acceleration. We will again use that acceleration form of Newton's second law, but what is the net force? What is different about this problem? So let's sketch out a force diagram and see these forces. We still have gravity and normal balancing out the vertical direction. We also have the same applied force acting to the right. But now there is a friction force acting to the left. Remember that we typically refer to the right direction as positive. And so since friction acts in the opposite direction, we're going to have that friction force acting to the left. Notice that this is not balanced. We have 10 newtons going to the right, 3 newtons going to the left. So that means we must have an acceleration. So the net force acting on the block is 10 newtons to the right minus 3 newtons to the left. This gives us a net force of 7 newtons to the right. Now we know the net force and the mass, so we can plug this back into our equation. And we're going to have 7 newtons divided by 5 kilograms. And that's going to give us an acceleration of 1.4 meters per second squared in the positive direction. All right, so can you mathematically describe Newton's second law? Specifically, where we're looking for that net force is going to be equal to the mass times the acceleration. And we're going to be looking at the acceleration is equal to the net force divided by the mass. And then being able to solve problems involving those two equations. So in your notes, make sure you have the mathematical form of Newton's second law and some example problems so you can solve those problems.